Imagine the starry sky. For millennia, humanity has looked at that cold, shimmering disk of light in the dark of night and wondered, what is up there? In 1969, we got our answer. We left our footprints there, planted a flag, played a little golf, and left. It has been over half a century since the last human departed the lunar surface. 50 years of silence. But that silence is about to be broken. Right now, we are standing on the threshold of the greatest event in the modern history of space exploration, the Artemis program, and its next crucial step, the Artemis II mission. This isn't just another flight. This isn't a nostalgic attempt to repeat the success of the Apollo program. This is the beginning of an entirely new era, an era in which humanity ceases to be a single-planet species. Today, we are going to break down exactly what will happen during the Artemis II flight, why we aren't planning to land on the surface this time, and most importantly, why this mission is critically important for the survival and evolution of all humanity. Settle in. We are heading into deep space. To understand the importance of the second Artemis mission, we need to look at the big picture. In 2022, humanity successfully launched Artemis I, the massive SLS rocket, the most powerful rocket ever to successfully fly, sent the uncrewed Orion spacecraft to the moon. It orbited our satellite and safely returned. Test passed. The machines work. But machines are one thing. Human life is completely different. Artemis II is the first crewed flight beyond low Earth orbit in half a century. 4 astronauts: Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency representative Jeremy Hansen. For the first time in history, a woman, a person of color, and a non-American will travel to the moon. This isn't just symbolism. It's a demonstration that space is now open to all of humanity. How will their flight unfold? The launch will take place from the Kennedy Space Center. The SLS rocket, burning tons of fuel per second, will propel the Orion spacecraft into a high Earth orbit. There, the crew will spend about a day checking all the life support systems. They need to ensure the ship can breathe, retain heat, and maneuver. And then, what is known in astrodynamics as a trans-lunar injection will occur. The engines will fire up again, and the crew will enter what's called a free return trajectory. This is a brilliant engineering solution. The spacecraft will swing around the moon at a distance of about 10,000 kilometers from its far side, and the moon's gravity itself, like a giant slingshot, will hurl them back toward Earth. Even in the event of engine failure, the laws of physics will still bring the crew home. The entire flight will take about 10 days. They won't land on the surface. And many ask, then what's the point? Isn't this a step backward? Not at all. And here is why. Let's be honest. The technology of the 1960s was astonishing for its time. But by modern standards, the Apollo flights were an incredible, desperate risk. The onboard computers back then had less processing power than the chip inside your smart kettle. The Orion spacecraft is the pinnacle of modern engineering. Artemis II must prove that modern life support systems can protect humans from harsh cosmic radiation. Once you leave Earth's magnetic field, the Van Allen radiation belts, you're exposed to solar radiation and cosmic rays. Orion is designed so that in the event of a solar flare, the crew can take shelter in a specially protected compartment inside the ship, using equipment and supplies as a radiation shield. Furthermore, Artemis II will test a new optical communication system. Instead of traditional radio, NASA will use lasers to transmit data back to Earth. This means that in the future, we will be able to receive 4K video from the moon in real time. This is a dress rehearsal. You can't build a skyscraper without testing the reliability of the foundation. Artemis II is a stress test of all the technologies that will allow us to take the next step. The main difference between the new lunar program and the old one comes down to one simple phrase: sustainable presence. During the Cold War, the goal was simply to get there first, plant a flag, and fly away. Today, the goal is to stay. Artemis II paves the way for Artemis III, which is set to actually land humans near the lunar South Pole. Why there? Because there, at the bottom of permanently shadowed craters, where sunlight hasn't reached for billions of years, there is ice. Water on the moon is the most valuable substance in the solar system. Water isn't just for astronauts to drink. By splitting water into hydrogen and oxygen, we get rocket propellant and breathable air. The moon will become our first extraterrestrial gas station. Parallel to this, the Lunar Gateway station will be constructed in orbit around the moon. Unlike the ISS, which circles 400 kilometers above our heads, the Gateway will be located in deep space. It will be a staging point, a spaceport where ships from Earth will arrive and from which lunar landers will descend to the surface. The flight of Artemis II is a test of the transportation system that will carry people and cargo to the station in the coming decades. But even the moon is not the final stop. It's a training ground. A flight to Mars won't take 3 days, but 6 to 9 months one way. Before sending people that far, where communication with Earth has a 20-minute delay and evacuation is impossible, we must learn to live and work in deep space. We must understand how long-term isolation, microgravity, and radiation affect the human body beyond Earth's orbit. We must create autonomous air and water recycling systems that don't break down for years. We must learn how to extract resources on another planet. Everything we will do on the moon, thanks to the foundation laid by Artemis II, is preparation for the greatest journey in history, a crewed mission to the Red Planet. When the Artemis II crew orbits the moon and looks back, they will see the Earth as no one has seen it in half a century, a tiny blue dot hanging in an endless black void. Home. This flight matters not just because of technology, rockets, or geopolitics. It matters because it will force us to look up again. It will inspire a new generation, the Artemis Generation. Engineers, scientists, dreamers, and creators who will understand that for humanity, nothing is impossible. Artemis II is the spark that will ignite the fire of a new space age, and we are the lucky witnesses to this moment. If you enjoyed peering into the future of space exploration, hit the like button on this video and make sure to subscribe to the channel. Next time, we will uncover even more mysteries of the universe and the technologies carrying us to the stars. See you in space.